Hi guys, welcome to the Avis YouTube channel. So today we'll discuss VRRP. So in future we'll discuss few more protocols. We'll do lab and all. So today we'll start with the VRRP. Okay, so initially we'll see what is the use case of the VRRP. We'll discuss the basics of VRRP, functions, timers. So this is the agenda basically for today's session. Okay, and we'll discuss the multicast address, what exactly multicast address we use in the VRRP. Then finally, after all these theory part, we'll see what kind of topology we are going to use for this practical. Then we'll do the practicals and we'll start checking like what are the sonic commands that we are going to use. So this is purely sonic here, right? So whatever commands will run here, so these will be around sonic switches, right? And then we'll see the verification process. So what are the methods we have? So by using some commands, we'll see the verification. By using TCP/UDM, we'll verify which device is getting the packet, right? And yes, we can do by using interface counters also we can verify, but moreover, we'll be using TCP/UDM to verify the packets, like we are receiving on the primary, on the secondary or not, right? And the same failover test. So we'll do a communication to the primary one, to the master one, and then we'll shut down the primary, and then we'll see at what point of time it will move back to the secondary, and then again we'll basically bring up the primary switch, and then we'll see after how many seconds it will fall back to the primary one again, right? So this is the agenda for the today's session. Okay, now let us start with the use case. First of all, what is the case of the VRRP? Okay, let me draw a topology initially. So assume we have a network running with some switches like leaf spine topology, right? And so I'm just using a very basic topology here. Okay. So let's say here we have the primary ISP, ISP1. Here we have the secondary ISP, ISP2. In general, what we do, let's say we have the users here. Okay. And they want to communicate to the internet. They want a communication to the internet, right? In that condition, assume we are running here a subnet of 10.0.0.0/24, right? Assume we are holding here dot one, here holding here dot two, and then further, I'll be using one of them as a gateway. So as this is our primary one, right? So I'll go to every single device and I'll configure a default gateway as 10.0.0.1. But now what will happen here? They can directly communicate to internet via the primary path. That is fine. But the moment this switch goes down, what will happen here? I need to go to every single switch and I have to actually configure this address as a default gateway. So I have to make sure that now I need to use 10.2. And then in future, once this will come back again, this is up and running, I need to again change back to 10.1. But you see, doing this is not the solution, right? We are changing the IP address on the default gateway basically on the users. And then again, once the primary comes up again, right? Then again, we are doing a change, right? So this is not a solution, right? So to have a good solution, we use actually VRRP, Virtual Router Redundancy Protocol, right? What this provide basically, the moment we start using VRRP, that allow us to use one virtual IP. Okay, so assume they both will be using first of all VRP, and VRP we always configure towards LAN. So here I'll be using the VRRP below this line. Or we can say over top of these two interface, I'll be using VRP to distribute one virtual IP address. So assume I'm using 10.0.0.10 IP address as a virtual IP address, VIP. Okay. Now what will happen here? The moment I'll be using VRRP, VRP will say, okay, one of the device is active right now for this IP address, and one of the other device will be in the standby state. So as of now, we are using VRRP. So the terms they use is master and backup. So one of the device will be master and one of the device will be backup. And now to all these users, what default gateway I'll be providing? I'll be providing 10.0.0.10. So now it means we have a common gateway, 10.0.0.10 all time, right? Now, first of all these users will go via as a primary router. Fine. The moment this device goes down, what will happen here? This device will take over the role, right? And then all these users will automatically go via the secondary path. And then again in future, once the primary router comes back up again, right, what will happen here? This device will take over the role. Now again, this device, okay, once this was down, this became master. Now, once this will be up and running, this will again come back to the backup state. And then this device, the one is now up, right? This will again become master, right? And then all these users will go via the primary path. So you see, it means after running VRRP, the engineer do not need to do anything, nothing. Without VRRP, the engineer has to do a numbers of things, changing the gateway, changing the stuff, right? Again, once the primary is up and running, the engineer has to change again back to the primary IP, right? But using VRP, everything is automated, right? And then we don't need to do any single change from the default gateway side. Nothing. Just configure VRP and then it will take care of this stuff, right? Now, one thing here, okay, here we have some issues. What issues we do have? I'll just rub something. Now, in this situation, the moment we start using the second device here, let's say this is master, this is backup right now, right? Now, assume this is down. The moment, okay, let's say this is up and running, assume, right? The moment they will communicate, this switch will be having ARP table, let's say, sorry, MAC address table, the port number 1, port number 2, and it will be sharing a virtual MAC address also. Okay, now, sorry. Now, so this port number 1, port number 2, okay. So port number 1 will be having that MAC address. Let's say the MAC address is assume A. For this IP address, the virtual MAC address is A. We are assuming. Okay. I'll discuss like how we can get the virtual MAC address also. So this switch will be having the MAC address table with port number 1 with MAC address A. Fine. The moment this device goes down, this device will be up and running fine, and all these devices are having actually that 10.10 is having MAC address A, and whenever they will send the packet out to switch, this switch will actually send the packet out towards port number 1 because switch is saying the MAC address A is actually via port number 1, but that is down. So how exactly this switch will get to know that I need to now communicate via this way? So what happens here, we never run VRRP on this switch. On the layer 2 switch, never we run, right? We only run the VRRP on these two switches. So what happens here actually is the moment the backup device take over the role and it will be master, in the background, what happens, this switch will send a GR packet, gracious R packet containing, so the concept is something in the very basics we discussed. Whenever any device will get the active IP address by using DHCP, maybe static method, maybe VRRP, maybe triple PoE, by any method, that device will check the duplicacy. So this packet is used to check the duplicate IP address. So the moment this device will be sending the GRP, it will contain source MAC address, what this MAC address actually, the MAC address A. And the moment the switch will be getting the GR packet containing the MAC address A, what it will do? It will actually remove the MAC address from the port number 1 and will learn on the port number 2. This is how the switch will get to know how that MAC address is learning and where to send the packet out to the new one. Again, once this will be down and this will be up and running, this will again send a GR packet, and then again by using MAC address A, it will remove from here and will learn on the port number 1 again back. So this is the mechanism using GRP. The layer 2 switch will get to know how to communicate to that MAC address or how to communicate to the active device, right? So this is how this VRP works, right? Okay. So this was the use case basically. How exactly this is working and what we need here, why we are using VRP. Okay. Now, and if you guys have any questions, you can put the comment in the comment section, right? And then we can reply. Okay. Now next, few more basics on the VRR. Some basically theoretical concept. When we talk about VRRP, first of all, this is open standard. No proprietary, right? Now, when we talk about this VRRP, that's a layer 3 protocol. So when, let's say, when we talk about any protocol that works on the layer 3, right? So that will be using some protocol number on the IP layer, right? So in the IP header, it use a protocol number 112. It use a time interval also. So here we use some time. It means between two devices, between two VRP devices, what exactly timer we are using. So we have the hello timer that is 1 second, and we have the hold down timer that is 3 seconds. So within 1 second, they will be sending hello packet to each other. And if they do not get a packet from the neighbor till 3 seconds, right, for another 3 seconds, they will see the neighbor is down. Now I'll take over the role. I'll be active device, or we can say master device. Okay. VRRP use a multicast address. So yeah, this is a multicast protocol. This is a multicast address 224.0.0.18. So the moment VRRP will be doing a communication, in the background, they are using 224.0.0.18 as the multicast address. They use a virtual MAC address also, right? Virtual MAC address is basically depending on the group number we use. So in the practical, I'll show you the group number, right? So let's assume we are using group number 10. So there will be some prefix like some values. Those are reserved actually for this VRRP, and then it will be XX. This XX is actually your group number. So if we are using group number 10, it will convert to hexadecimal. It will be A. So it will be 0A that time. It means if we are using 10, group number 10, automatically the virtual MAC would be, this will be remain same every time in all the versions, right? And then it will be 0A here. If I'm using, let's say, 11, it will be 0B, and so on basically. So whatever number here we put, it will convert into hexadecimal and will be using as a virtual MAC address. Okay. Few more theory we do have, but we'll talk about later. And in here, let's talk about the role. So here we use two role. One is master, one is backup. Okay. Yeah. Pretty much we have this one, right? So now let's go to the practical. We'll see the topology, what topology we are going to use. And with the practical also, we'll see few more theory one by one. Okay.